All right, I really like integrals net change. And I think that in general, it's something you'll find to be typically really easy. But like I said, it is this, there are questions that pop up, and the wording is what I think gets you. So I just want to make sure we can understand the wording, especially if there's a question like this on the mock exam. So we have, and actually we're going back to, which is kind of weird, displacement and distance. So if you think about what we talked about in position, velocity, acceleration way back with derivatives, now instead of like being given position and finding velocity and acceleration, you're going to be given velocity typically, and you have to use it to find acceleration and position. So the most common questions are typically giving you velocity and asking you to interpret position or acceleration. So in order to be able to interpret it, you have to know the difference between distance and displacement, because distance is completely different in terms of moving forward and backwards than displacement. So displacement is your overall change in position. Displacement is allowed to be positive, negative, or zero. So displacement can be negative. Distance is never negative. So displacement could be positive, negative, or zero. So think of the concept 2 steps forward, 1 step back. So I could go 2 steps forward and then take 1 step back. My displacement at this moment is positive 1, because my end point is 1 step forward from where I started. My total distance traveled, though, is 3. So it's like using gas in your car. You can't, even if you start at the school, go to work, and then come back to the school, you used gas. You drove a distance, even though your displacement would be nothing, because it started and ended in the same spot. So the total distance traveled in the 2 steps forward, 1 step back would be 3, but your displacement would be a positive 1. To find displacement in terms of an integral, we're going to talk about initial position to ending position. So we'll start at time A, and we'll end at time B. If I want to find displacement, which is kind of like position, what would I be integrating? If I want a position or displacement, what do I have to integrate? Perfect. So to find displacement, we're going to integrate velocity with respect to our time. So think back to fundamental theorem of calculus. It said if you integrated a function, v of t, from b to a, or a to b, whatever order you want to talk about, then that was equal to the capital letter F, right? This is like lowercase f, and then went to capital letter F. In our case, though, when we integrate velocity, we go to position. What letter do we typically use for position? S. So this would be like S of B minus S of A. So again, you're integrating velocity and finding position. We say in order to find your new location that your new position equals your initial position plus displacement. So again, this represents the displacement. This is where that plus C kind of tags along. And that plus C is like your initial condition. You don't see it necessarily, but that plus C is kind of like your initial position. So that's what this formula right here is talking about. To find total distance, we have to think of the problem in a different way now. To find distance, what did we say distance had to be? Distance has to be what? Positive. How do you make a function always positive? So the distance is simply the absolute value of velocity. So don't you remember when we talked about distance and displacement, we talked about position, velocity, and acceleration, and there was that one question where you had to find all the zeros of velocity because you had to find where the particle changed direction, and then you had to find position, point A, point B, add together. Position, point A, point B, add together. So like, this is that same idea now. To find the area under the curve, or to find that total distance, I have to talk about the absolute value. So that's what this little block here says. To find, you can also find when the object is moving in the negative direction by breaking the integrals into pieces and subtracting the value of the integral for the area under the curve. And that should make sense. So if this was your velocity function and it looked like this, you could actually subtract this integral right here to make it be like a positive. So remember, our rule is if you're going from, let's say, point B to point C, it would come out negative. But if you take the negative of that, it would become positive. So again, you could take all these negative parts and you could subtract them to make them positive as well. So, like I said, the only way to really do this is to walk through a problem using all that terminology. What's nice is this is similar terminology to derivatives with position, velocity, and acceleration. We haven't talked about derivatives with PVA for a really long time. So it says, suppose the velocity of a particle moving along the x-axis is given by the velocity of 6t squared plus minus 18t plus 12 from 0 to 2. So we have a really small increment. We're only talking 0 to 2. When is the particle moving to the left, moving to the right, and when is the particle stopped? So think back to derivatives or physics. When is a particle not moving? When the velocity is 0. So we're given velocity. The particle is not moving when the velocity is 0, so we're going to set our function equal to 0. I saw GCF, so I took out that 6. It'll make factoring so much easier. So there are 2 times at which the particle is stopped. So again, if it said when is the particle moving to the left, right, and stopped, you would say the particle is stopped at t equals 1 second and t equals 2 seconds. And if they asked you to explain, it would be because the velocity is 0 at these points. So again, I know this doesn't necessarily ask you to give those explanations, but those are those AP writing to justifies. If 1 and 2 are where the particle is stopped, and I'm only talking about the increment from 0 to 2, what do I have to be concerned with to find the left and the right? So what am I looking for to determine if the particle is moving right or moving left? Yeah, whether it's positive or negative, and what has to be positive or negative? So I guess which function are you referring to? Which? Okay, so if I compare when position is positive, I'll know what direction it's moving. I know, and that's okay. I'm trying to get you to think, and I know the three of you are in physics. So we have those three that are answering this question right now. So think about who told me when velocity is 0? Right. So you told me when the velocity is 0, the particle isn't moving. Think about me. I'm moving right now, right? I stopped. My velocity became 0. What was my velocity from where I started to here? Positive, right? Because I was moving forward. If I stop and then I move backwards, what happens to that velocity? It becomes negative, right? Because it's not speed. Speed is the absolute value of velocity. So speed is always positive. But if I put my car in forward, and drive, rather, forward. If I put my car in drive, my velocity is going to be positive. If I put my car in reverse, my velocity stays quote-unquote positive because cars are speeds. However, my direction would be negative because I'm going backwards. So the particle will be moving to the right when the velocity is positive. It goes to the left when the velocity is negative. So I'm concerned with what's happening between 0 and 1 and 1 and 2 in terms of their signs, in terms of velocity. So between 0 and 1 is a half. If I plug a half in over here, a half minus 2 is negative. A half minus 1 is negative. The negative times a negative is a. So the position is in the direction of the right because the velocity is positive. So it is going to the right from 0 to 1. You can include 0 because 0 is where you start. You do not include 1 because at 1 it is stopped. It is not going right at 1. At 1 it is not moving. Okay? How about from 1 to 2? You plug in 1.5. That's going to be positive, negative, positive. So it's overall. Therefore, the position of the particle is going to the left from 1 to 2. At 2, we are stopped again. So it is not a bracket. It is a parenthesis. This is kind of like what we did in derivatives, except for you were pretty much given the position, and you had to find velocity and then answer these questions. So now we're given the velocity, so we can just answer them. I want to answer them about displacement now and distance. I want to know, how far did this particle move? Where does the particle end up? Where does the particle start? So it says the particle started at initial position S of 0 equals 3. So initially this particle started at 0, 3. That's a key piece of information. We said that displacement is the integral of velocity. So what is the particle's final position? Well, final position is new position, which is displacement plus initial. So let's find its new position. So we want to find the integral from 0 to b of t dt. So the antiderivative of velocity, once again, because I pulled out that GCF of a 6, you can keep that 6 pulled out because it's a constant. So this will be like integrating from 0 to 2 of t squared minus 3t plus 2 dt. Cubed is 8. 2 squared is 4 divided by 2 is 2. 2 times 2 is 4. Minus 0. I distributed my 6 because I got rid of the fraction. Instead of trying to like combine these like terms, I was like, oh, well 6 times 8 thirds is going to get rid of that fraction and give me 2 times 8, which is 16, minus 36, plus 24. I would much rather add big numbers when I would a fraction. So what's your displacement? So the final displacement is 4. Is that my answer? The question is, what is the particle's final position? What does this 4 not incorporate that they gave me in the problem? Yeah, S is 0 equals 3, right? It didn't include my initial. So what you have to do is treat that initial like that plus C that we don't account for. So its final position is your initial plus your displacement. So again, that's kind of like that fundamental theorem of calc where you have to take back into account this 3. So it's 3 plus 4, which is 7. What does that mean in terms of functional looking? What that means is that S of 0 equals 3. This means S of 2 equals 7. That's what that means. This means the position at time 2 is 7. The position at time 2 is 7. Your position function would be this antiderivative here, right? So your position function would be 6 distributed to this, so that's 2t cubed, minus 9t squared, plus 12t. What do we add to our position function? We usually have a plus c. What is my c? 3. C in it how would the displacement in the position function be altered if we were talking distance? What would you have to do differently to find the distance? So again, we said distance is the same integral as displacement, but you talk about the absolute value. To know when the absolute value, what did I do when I drew you the picture? I said you had to subtract the negative areas. So you want to subtract the negative times velocity. Why is this now so important? When is velocity negative? And 1 and 2. So to find the total distance, I have to add from 0 to 1, and I have to subtract from 1 to 2. Because since velocity was negative and the particle was going backwards, if I want to know how far it went backwards, I need to subtract or minus the minus. Does that make sense? So my distance function is going to be the antiderivative from 0 to 1 minus the antiderivative from 1 to 2. I have some choices here. What do we say about these functions, right? We say that the integral from 0 to 1 of v of t dt is actually s of 1 minus s of 0, right? That was our very, very first definition. The antiderivative of velocity is the position at the upper minus the lower. Minus the next part. So it would be s of 2 minus a minus, so plus s of 1 again. Again, it's s of 2 minus s of 1, but you have that negative out in front. So really what we're saying is 2 s of 1 minus s of 0 minus s of 2. Well, what's s of 0? 3. Good, Sam. Thank you. What's s of 2? What's the only thing I need to know? 1. So instead of plugging all of this into that huge function a million times, we just said s is this. So plug in 1. 2 times 1 is 2. Minus 9, so negative 7. Negative 7 plus 12, 5. 5 plus 3, 8. So this is 2 times 8 minus 10, or 16 minus 10, so we get 6. So it's total distance traveled from 0 to 2